But the third step is the environment, and arguably the most critical. In the environment, this encompasses the backend dependencies as well as kind of the data that you want to replay. So the backends, when you're replaying traffic, the backends have to contain the same sort of data and the data state as when you replay the traffic. Now, this is not a new problem. This is the same problem that exists when you're running tests as well. And so people kind of get discouraged. They're like, oh yeah, we can't replay traffic because we can't reset the state of the data. You have the same problem when you're running normal tests. But the idea is with mocking and modern mocking technology, this becomes a bit of a less of a concern. I think a lot of companies nowadays are looking up like ephemeral environments. It still doesn't solve the problem of the backends having improper data state or needing to be seeded with the right data and the data test data being burned up every time. If you do use some sort of mocking technology, it can actually repeatedly be, refreshed and stood up. Some mocks out there even never run out of data because they're smart enough to repeat. And like, if I say delete user Nate, once I've deleted user Nate out of the database once and I do it again, it's going to say, well, there is no user Nate, you deleted it. But with mocks, they can be configured and parameterized so that, whatever user you say to delete, it's always going to be deleted successfully. And some of the more modern mocking tools, like Speedscale is one of them. I think virtual service technology is to a point where you can do that as well. The mocks are a lot more sophisticated and scalable. When we get to the point of building an environment, the question of environment scope comes up a lot. A lot of people will at this point say, well, hey, we've got, DynamoDB, or we've got Oracle database, or some sort of backend system of record that's very far down the line. And they say, well, we need that to be mocked. Well, not really. Like if your shopping API, like the service under test here, is what you're trying to test, you really only need to mock what's immediately behind the service under test. So for example, you would only need to mock this internal API being updated, this red square that's kind of second down. You would not have to mock the DynamoDB that's behind the internal API that's being updated, because the internal API that we mock would actually act and behave as if you would mock the Dynamo database. Does that make sense? So it's basically acting like it already had that next hop communication. And so we're kind of abstracting the need for that database away. And so an easy way to think about this whenever you're looking to build an environment for a particular API is to draw a circle around that particular API and in the architecture diagram. And then wherever there are intersections with the line of the circle, these are either test drivers or load drivers that you need to account for, and you need to figure out a way to simulate the inbound transactions. And then on the back ends, you need to be able to mock these backends. You need to figure out a way to simulate responses coming back. So those backends that are outside of the circle, those are out of scope for the load test, meaning you're not testing those services. The real service that you're wanting to test is inside the circle. So you don't care if it's the real system or not. You just need a response that comes back in order to test and stress the service under test. I hope that makes sense. And so this is kind of the way we think about like scoping the environment when you're on your way to being able to repeatedly load test that particular API. And so once you've actually kind of figured this out and you figure out a way to drive the load into your particular API, and then you've figured out a way to mock these backends, you are left with a situation where you've got a simulated end-to-end environment. You can think of this as like a simulated end-to-end environment. You can think of this as a component level load test. But this one concept, this singular concept of being able to isolate your service under test is, in my opinion, the key to unlocking velocity. Like I started out with, a lot of these retailers have what people are calling like microservices monoliths. We got away from monoliths into distributed architecture so we can make changes more quickly, and we distributed and we broke up the different functions into like payment APIs, fulfillment APIs, user APIs, etc. But now everything is so tightly coupled that we can't make changes to singular APIs because they'll cause cascading failures across to other APIs and bring down the whole system. And really, in order for you to move quickly, And with all of the dependencies that are involved in an architecture nowadays, you have to use mocks in order to isolate and break up this problem into manageable chunks. And it doesn't have to be one service in between, your load driver and your mocking engine. You can start to expand out and test subsystems. And so you can actually eventually move up and out into an end-to-end test. And by the way, I'm not advocating against end-to-end testing. I'm just advocating against doing end-to-end testing immediately after everybody's done development. It would be like putting a plane together, a prototype plane, putting a plane together and trying to take off. Whereas this approach here with isolating the services before you actually do an end-to-end test is like testing the landing gear independently in a harness and making sure it can take repeated drops, and testing a wing in a wind tunnel and modeling different sorts of lift conditions, precipitation, making sure it can flex to the desired tolerances that you want before you attach the wing to the airplane. So it's kind of like a component level load test. And once you've isolated it using mocks, then you are sure, hey, this will do, 3000 DPS. We know it can respond within 50 milliseconds, maybe 100 milliseconds on the upper bound. It uses X number of milli-CPUs and 20 megabytes of memory. Having all those metrics going into an end-to-end test can be hugely valuable and really accelerate the rate at which you make changes, and you can catch problems before they actually get caught in an end-to-end test. So this is kind of the secret to unlocking more velocity and doing repeatable load tests, understanding immediately when you make a change if things are going to break.